So our next speaker, I'd like to introduce Jim Myers with the Aerospace Corporation. He is a Senior Vice President of Civil Systems Group, which operates in the national security interests of the United States and its allies to broaden the company's business and technology base. They combine deep technical expertise with industry-leading innovation to help the U.S. government, allied governments, and commercial customers solve some of the world's most complex systems engineering integration challenges. I also love, Jim, how your bio shows how you support a lot of the STEM and workforce efforts with Math Counts, VEX Robotics, and the Air Force Association Cyber Patriot. So please welcome Jim Myers. Thank you.
Thanks very much. So it's a privilege to be here today, invited by New Space New Mexico and DIU, to speak to everyone assembled here in Albuquerque for this workshop. As my title slide indicates, success in space will be enabled by a community of people and organizations working together. So Major General Olson, I was listening, taking notes. He talked about protect, defend, and secure. So not just protect and defend, but protect, defend, and secure. He talked about partnering to win. And then Dr. Okoro talked about promoting space commerce and ensuring that we are, as in the US, the partner of choice. So let me tell you a little bit about Aerospace Corp. I won't do much of this. If you haven't worked with us before, we operate the one federally funded research and development center, FFRDC, for space. So we view our customer community as the entirety of the space enterprise. Now, we also operate in Albuquerque. We have more than 100 employees here in Albuquerque, serving all facets of the space enterprise, as well as the US nuclear security enterprise. And we are, as I mentioned, we serve a wide range of customers across national security, civil, and commercial space, and related domains. And we have offices close to our customers, and our customers are nationwide. And we're also positioning ourselves close to STEM centers of excellence for obvious reasons. Fundamentally, we exist really to help our customers achieve mission success. We are a not-for-profit. I mean, we're not in it for profit. We're in it for our customers. So is this the most exciting time in the space business? Well, I joined aerospace a couple of years ago because I thought so. Our CEO, Steve Isakowitz, frequently says we're living in the most exciting time in space. He feels that way. There's lots of enthusiasm. This group assembled here. There are conferences all over. And when you listen to Dr. Okoro and national leaders spending a lot of time and effort on things like ISAM. I mean, I can't even imagine ISAM. I wouldn't even have conceived of it, 20 years ago. And there's very significant policy that's been written on it. Now, excitement. So what's the physics definition? A state of increased energy or activity, and I think we are there. So if you want to talk about activity, let's talk about cash. So tremendous amount of investment. I remember the company I was working before I went to aerospace. I remember being called by bankers, investment bankers, back in 2015, 2016 timeframe. If investment bankers are calling you, then there's something serious and significant going on, because investment bankers don't like taking risk. It's different than private equity or VC. So they even saw this industry as in a major growth mode. So I took a shot at a top 10. There's nothing special about it, but I thought it would be interesting for you to hear. This is just literally news headlines from the last week or so. And the range of things that's happening in space, whether it's civil, commercial, other parts of the government, other governments, it's incredible. So SDA, Space Development Agency, they put out a draft solicitation for 100 satellites for Transport Layer Tranche 2. Eutelsat, you're probably aware that Eutelsat and OneWeb came together. Why? Because traditional space-based satellite services are changing rapidly, right? So Eutelsat's having trouble with their broadcast sales. So they're looking for uplift from OneWeb. So that was a headline. Intuitive Machines, their lunar lander slips to Q3 of the calendar year. Now, think about that. A commercial company planning to do a lunar landing. And there was another commercial company, a Japanese company, that almost did it. They didn't quite make it. It's a couple of weeks ago. So they're slipping to Q3. China's space plane conducts proximity and capture maneuvers. That's a headline. After being, as part of their 276 days in orbit. NASA announces a hybrid contract approach for space station's deorbit vehicle, where they would go cost plus for the development portion and a fixed price thereafter. Our US government is expanding space situational awareness cooperation with international partners. So back to this theme you've been hearing about partnering. It's not going to happen otherwise. The UK Regulatory Authority approved the Inmarsat Viasat merger. So two great companies coming together with some ideas on pretty substantial synergy. The Czech Republic signs the Artemis Accords, the 24th signatory for Artemis. It's a big deal. Now back to money. There's no details on what those numbers are. I'm going to tell you in a sec. So America's SPAC-funded new space industry crashing. That's a pretty strong headline. The volume of early stage funding has dropped 50% in 2022 over 2021. So the numbers that I have about, and this goes back to my getting a call from an investment banker 8 years ago. In 2015, the private investment in space was at about 20 billion. Those are the numbers I have. 2022, we got back to 20 billion. And this chart doesn't show you those years, or the 2022. But between 2016 and 2021, those 6 years, it was over 200 billion. So 30 to 35 billion a year. And there were some $50 billion years. I mean, just huge. Now, the numbers are, quote unquote, coming back to earth a little bit, but it does show you that there is excitement in space. And then the last headline, my top 10 that I wanted to share with you, is Space Force announcing that they are opening a commercial office in Northern Virginia. So this is commercial services and recognizing that they need offices on both sides of the country. So there is a lot going on. As far as how aerospace fits into that, our US government customers look to us to help them with information. I mean, literally to help them call through all the activity, whether it's commercial or other, and understanding those capabilities of the commercial players. And we're seeing that with all of our customers, whether it's a national security customer, an intelligence community customer, a civil customer, and for that matter, commercial customers. Commercial customers are looking for how they can better connect with government and be more effective with government. So, so with all that, we launched something we're calling Commercial Space Futures. We launched an office about 18 months ago to do this very thing, to try to create the theme of the conference around Nexus, to try to create Nexus like that. We've done analysis of more than 350 commercial service providers already in the past year. So, so government knows, and Dr. Okoro's right in the middle of this, government knows that they need to adapt, right? Adapt, adopt, and bring the best hybrid offerings to the fight, whatever that is. And the demand signal is clear. I'll give you an example of how aerospace plays there. NASA has been very forward-looking, forward-leaning for many, many years. You heard the reference to COTS earlier. They've been infusing commercial into their architectures for a while. And so when International Space Station winds down at the end of the decade, NASA is already planning to encourage and has let contracts for commercial space players, and we are supporting NASA in that endeavor. DoD a week ago issued the National Defense, enough about money, they issued the National Defense Science and Technology Strategy. 3 points that I'll reference from that: focus on the joint mission by investing in information sharing. You're going to hear later from ISAC, which is a cyber version of information sharing. Create and field capabilities at speed and scale by fostering innovation, back to Dr. Okoro's remarks about innovation, and ensure research and development foundations through recruitment, retention, and talent development. So that's a defense perspective, but it's not limited to defense. These themes are, you'll see them in civil guidance, including, and they're referenced here, the recently released National ISAM Space and Technology Strategy, the Cislunar Space and Technology Strategy, and the LEO R&D Strategy. So we believe that integration and acceleration is national level strategy with implications down to warfighters, civil servants, and commercial operators, and to include our allies. They're all watching how we tackle these challenges. Now, for those of you who got a chance to attend Space Symposium, and I think General Shah is part of the agenda later today, his words were, it was one of the best talks I've ever seen. And so keeping in mind that our adversaries, our competitors, and our partners are watching, he talked about living through a third space age, marked by the conjunction of the space sectors, meaning civil, commercial, defense, international, and that the integration we're talking about spans national security, civil, and commercial in a way that we've not seen before. So integration, big theme. And so as we think about integration and conjunction, you'll hear the term conjunction used in space traffic management and space traffic coordination circles, because you don't want conjunctions. But in this case, we do. We want groups coming together. It's much of what this conference is about. And we're seeing that happen already with commercial and civil launch partnerships. Those are in place and very effective. Getting humans back to cislunar space in a permanent way. So Artemis is leading us there. And there are many other examples. I'm gonna get a little more serious here for a second. I don't think that I would do justice to this talk without saying a little bit about Ukraine and the significance of the Ukrainian government and military still being able to operate. And General Shah talked about this too, the importance of commercial partnerships and the importance of commercial capability. So this is my personal view, it's not an aerospace view, but without Starlink, without Viasat, without Maxar, would the government, would the military, would they still be standing? Probably not. And this imagery that we've been getting is thanks to commercial players. And we've all read about what Starlink has done from a communications point of view, making broadband possible in an environment where it wasn't. And if you're wondering, because you don't get this daily in the news, if you're wondering, have things kind of calm down? Cyber is one of those things that is happening all the time. And I'm not sure what the ISAC is going to talk about today, but there's no doubt that Russian aggression includes ongoing cyber attacks. So, and cyber is now something we are very serious about over the last few decades, about protecting our space assets from cyber threats too. So you got cyber threats on the ground. You've got this, offensive, this war that Russia has initiated, and it extends to the space domain. And amongst all the things that General Shah talked about, he talked about the movement of aggressive tactics and space being a warfighter domain as the most dramatic change of all. It's pretty sobering. And General Shah kept talking about, we're all in this together. We all are going to go to the fight together. So back to integration. So sorry about the serious moment. So we're going to be successful, and you've heard other folks talk about this today already, as an integrated enterprise. If we don't do it that way, we won't. We have to be interoperable. We have to have standards. You can't do something as complex as this without that kind of approach. We have some examples of that so far. We're moving to a place where we're going to have evolvable ecosystems, right? So it's not static anymore. You don't put up, I started my career doing satellite design. You don't put up a satellite and that's it. It's much more dynamic than that. So the challenges are complex, but being that we're all in this together, I think there's some fabulous opportunities for us to collaborate. So what I'm going to do is walk you through some of the subject matter that you guys are going to touch over the next couple of days and give you some examples. So this video is even more dynamic than me. So watch this. This is pretty cool stuff. So go back to Sputnik in 1957, and this is an attempt to show you exactly where everything is from 57 to today. So 5,000 satellites today. In 2030, the estimate is 60,000. Of course, this just is going to take you to today. So we've got to have shared taxonomies. We've got to have integrated approaches. Otherwise, we're not going to have mission success. And as this graphic matures, you'll see that space traffic management and coordination, we need it, right? It's pretty busy up there. Think maritime, think aviation, where they have traffic management regimes. You see the geostationary belt, you see low Earth orbit, which covers a bunch of altitudes. And then you see some highly elliptical orbits. There's a lot going on. And we're just starting to get our arms around how to manage all that traffic. So to keep space sustainable and safe and economically viable, we've got to have shared norms and values and a sustainable supply chain. So a number of the sessions over the next few days are going to treat these important topics. Dr. Bhavya Lal, in her keynote, will probably touch some of this. And then we'll have an international perspective from Dr. Goswami right after I conclude. And then, as I mentioned, Space ISAC. So let's talk about debris. If you're not aware, in 2009, Iridium and Cosmos collided. Another pretty interesting graphic. Space traffic coordination is an intense focus for Aerospace Corp. We're investing in it. We're doing work for customers in it. We launched the Space Safety Institute, intended to assist our customers in areas like space traffic coordination, human spaceflight safety, debris management. There is significant debris even today, and you'll see year over year the debris field. The National Orbital Debris Implementation Plan calls for R&D of U.S. capabilities in debris mitigation, tracking, and characterization, and remediation to enable sustainable operations for decades to come. This has to happen if we're going to realize the potential of LEO. and cislunar. The moon presents a even more challenging problem because if we had some sort of trouble on the moon, we'd have debris that would be there for millennia because of the lack of atmosphere around the moon. The moon has much less surface area. There are 250 landings already planned over the next decade. So safe, sustainable operations in the moon, on the moon, and across cislunar. So the second area I wanted to touch that's part of the agenda for the next couple of days is creating and fielding capabilities at scale and speed. Our national space policy, this is our policy, calls for government agencies to use commercial solutions to the maximum extent practicable and consistent with applicable law. So you can imagine with expanded commercial capabilities, national missions are already being accomplished through hybrid architectures. To do this and to sustain this with all the investment and all the new companies coming along, new space that is the title of this conference. We have to identify providers and capabilities, understand their readiness, connect them at the point of need, develop confidence in their capabilities, accelerate adoption, integration, and deployment. That's why Aerospace Corp stood up this Commercial Space Futures Office. We put that in place to appeal to all those kinds of needs. There are already 80 companies developing capabilities with one or more of the foundational layers of infrastructure for cislunar, for sustainable cislunar ecosystems. And that's at least our count. There's probably more. With that, we'll need in-space test beds and proving grounds in order for there to be confidence that these capabilities are actually going to work. So cislunar. We believe that there's substantial planning and coordination that's going to have to happen for these foundational space infrastructure layers to happen. Here are the 12 that we've helped to define. Think of it like you're going west in the 1800s and there's no infrastructure, right? You need power. You need to know how to get places. You need communications. You need shelter, right? All the basic stuff. And now in space, of course, you need environmental control systems and so forth. So this is a huge deal. And if we're going to sustain ourselves in cislunar and permanently be on the moon, there is a ton to do. The 80 plus companies I mentioned are all working on their own solutions to one or more of the capability needs in these areas. How's that going to work? If they're all working on their own thing, which is good from an entrepreneurship and an innovation point of view, but how does it all work together? How does it become interoperable without standards? The International Space Station is a great example because you've got modules from other governments. It all works together. That's an example. So we can do it. But there's a lot more to do. We need coordination. We need a common engineering development environment, and we need integrated planning across the enterprise. So it's starting to happen. There is a task force called the AIAA Cislunar Ecosystem Task Force. So they're starting to think about this. Now, let me take you back to Symposium for a second. General Shaw commented on cislunar. He said, cislunar is a relevant area of operational responsibility. Cislunar is the domain of focus for national security space. And there's a bunch of references that I'll share with you, the National Cislunar Strategy, and Aerospace Corp has written some papers on this. Look at that image, right? That is Artemis 1 in cislunar space in a highly elliptical orbit beyond the moon. I mean, that's pretty amazing. Third area, which Dr. Okoro talked a lot about and is critical to cislunar success, and that's ISAM. So there was a reference during the panel to a consortium. That consortium is COSMIC, and I'm going to say more about COSMIC in a second. But if we're going to build systems and ecosystems in cislunar space, in LEO, anywhere else, it's not a one and done process. We have to build things that are going to last, that are going to evolve, that are going to adapt, that can be serviced. So tomorrow, you're going to hear from Greg Richardson. He is the leader at aerospace for our ISAM work. And he is executive director of a new whole of space consortium launched by NASA to coordinate and develop in-space servicing, assembly, and manufacturing, ISAM, capabilities. It's called COSMIC. I'm not going to say any more about COSMIC because Greg will talk about it tomorrow, and he'll do a much better job than I would. So a little graphic on COSMIC. It's one of multiple coordinated whole of space efforts that will enable us to develop integrated, scalable infrastructure with interface standards that we will need in order to function and bring the potential of cislunar space operations. So ISAM in and of itself, you think of as a machine-to-machine type of activity, right? Where we're doing assembly and manufacturing of capabilities in space. Robotic servicing, AI-enabled. So if you were watching closely, this slide is repetitive. I had it a couple ago. And when I put this presentation together, I left it in there on purpose because I had it twice. And why did I do that? Because humans are fallible. So this is not new content, but I am a little worried about all this stuff being done without humans in the loop. I'm trying to avoid obsolescence, but that may not be possible. So I'm going to now segue to the fourth topic that you guys are going to touch over the next couple of days, and that is workforce. So super important area for aerospace core space workforce, STEM. We all know that we need to cultivate a robust workforce for the next generation of space challenges and opportunities. We have to strengthen our STEM approach. We have to strengthen the pipeline. Think about ISAM, right? ISAM is basically a new thing. We need a workforce with skills and are going to think about what they do in an evolvable, adaptable way. Designed maybe on Earth, but built and deployed in space. Serious digital engineering capability needs there. We have to emulate as-built and deployed systems, right? For cislunar, we're going to need science and engineering knowledge for developing new capabilities. Think about the radiation environment. Think about there was a solar power discussion, pretty significant discussion here a little while ago. Lighting, there's parts of the moon that no lighting. And then there's other parts where it's very bright. So all the orbital dynamics, which is a big deal when you're trying to maneuver. And then how about just dust on the moon? How do you manage dust? There's a lot of things that are different and will require different engineering approaches. And then there's universities, a super important partner for all this work. They have fabulous intellectual capital at universities. We need to make sure that they're part of this solutioning. There's tremendous innovation that happens in universities, and they will be an important voice in the room. Again, demonstrating the importance of diversity and diverse opinions, diverse backgrounds. We will not bring the best innovations to light without hearing from everyone. So back to Aerospace's Space Workforce 2030 pledge. We have commitments now from senior leaders of 30 companies, 30 organizations, including Aerospace Corp, pledging to boost the number of women and employees from underrepresented groups into the space technical workforce and into leadership tiers in our industry. So sponsoring STEM programs to reach more than 5 million underrepresented K-12 students annually is the pledge, and a national space intern program to build and sustain an opportunity pipeline into these member companies. So we're at 30 companies and looking for more. So some closing thoughts. Being the space cadet that I am, this convergence of national priorities, of interest in this domain, of investment, has brought us all together, right? We're all coming from different places, different backgrounds, but all very, very interested in where space is going to go. This doesn't work without a safe and sustainable space ecosystem. That has to be primary in what we're doing, and Dr. Okoro's work serves that. The pace of innovation is unlike it's ever been, so we need to ride this tide in a collaborative way to solve hard problems. So you may not recognize this because it hasn't flown yet. I'm really excited about, one of the things that's nice about NASA is it's a civil agency. We can talk about the work that they do, right? I worked on James Webb Space Telescope 20 years ago. We can talk about it. This is an image of the Habitable Worlds Observatory. And NASA announced that, well, it doesn't exist yet, but it's imagery, that project, it will go into a stable, another Lagrange orbit in cislunar, and it will be assembled, manufactured, tested. Everything will be done in space. And it will look for signs of life on Earth-like exoplanets. Why is that important? Because there's an image from JWST. One of the things we all have to do is get K through 12 excited about space. If we get them excited during that period of their lives, then they may become like us and want to be involved with space. Projects like James Webb, so captivating, and to imagine that we are going to build the next great observatory in space is, for me, incredible. Let's move to Apollo. So I am old enough, just barely, I'm old enough to have been one of those little kids sitting in the living room or the family room, whatever, with the little black and white TV, watching that back in 1969. So guess what? I studied engineering, and the rest is history. Very, very compelling when we're able to do this. So we won the first space race, right? We were the first ones there. And from my point of view, it demonstrated soft power, right? We were in the Cold War, and it was a great example of soft power. We got there first. We are capable of this. Everyone can see the moon, and we were there first. We broadcast those images across the globe. Imagine what that meant to people all over the world. Now, global competitors are making inroads. We are still the leader, I believe, as a space nation. Think about what we do today with our space assets. We bring broadband internet to underdeveloped regions. We democratize the flow of information to underserved populations. And we have the opportunity to redefine the art of the possible for all of our planet's citizens. So how about Artemis 2? Webb, Artemis, and other transcendental achievements in space exploration are truly inspiring. I mentioned the Habitable Worlds Observatory, which will build on Webb's momentum, but will be assembled in space and will be designed for robotic servicing. Absolutely incredible. And then there's Artemis 2, which is a really big step for the US returning to cislunar space and specifically to the moon. I've really enjoyed the opportunity to speak today on behalf of the Aerospace Corp. I look forward to working with all of you here to embrace these challenges and opportunities as we venture out together into cislunar space and beyond. Thanks.